Anyway, all right. So let's see how far we can get in the lesson 9 notes. You ready? Okay. Zach and anybody got that one? Zach and Sion were working on predicting the number of quilt blocks in this pattern. How many quilt blocks are in the first pattern? 7. How many quilt blocks are in the second pattern? Is it? Do I trust you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. How many quilt blocks are in the third pattern? Is it? Or you just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 17, 18, 19. Awesome. So you guys already know what's up, right? Yes, sir. What's happening? How much each time? 6. Okay. So you can see that it is going up by 6 each time. So that means it's an example of a arithmetic, because you're adding the same amount. Would this be discrete or continuous? Discrete, good, because we just have individual patterns, we don't have decimals. All right. Okay, so Zach says, I got y equals 6n plus 1 because I noticed that 6 blocks were added each time. So the pattern must have started with 1 block when n equals 0. So remember what we did on the tables yesterday where we had to walk it back and find out what it was when x equals 0? That's what he did here. He's like, if you're adding 6 each time to get back to the 0 one, you would subtract 6, right? So you would, right? Okay. Okay. Sion says, Lindsay, can you talk a little bit less loudly? Thanks. Sion says, I got y equals 6 times n minus 1 plus 7 because I noticed that at n equals 1 there were 7 blocks and at n equals 2 there were 13. So I used my table to see that I could get the number of blocks by taking 1 less than it, multiplying by 6 because there's 6 new blocks in each figure, and then adding. That's like so complicated. Don't you think that's really complicated? Which one do you like better? Yeah, the first one. What do you think about the strategies that Zach and Sion use? Are either of them correct? Luis, you said they're both the same. Because if you take 6 times n minus 1 plus 7 and distribute the 6, what do you get? Right, 6n minus 6, because you remember you have to distribute the 6 to that also. Okay, and then if you combine those, you get 6n plus 1, so they are the same. Okay, so they're both correct. They are both the same. In my humble opinion, Zach's is easier. I don't know, maybe you think Sion's is easier. I got lost like in the second sentence there. I noticed that at n equals 1 there were 7 blocks, n equals 2 there were 13. Yeah, I don't know. Okay, we all right with that? Okay. And Zach's method has been the one that we have focused on the most. Okay, the next problem Zach and Sion worked on was to write the equation of the line shown on the graph below. Will you guys write the equation for that line? What points, what 2 points are you focused on? This one right here? Okay, so right there. That's kind of gross though, so let's pick one where it actually is on the grid. Okay, so how far down did it go? And how far over did it go? So that means the rise is -2, the run is 4. What does that reduce to? -1/2. Okay, so that, Nathan, is the slope. What's the y-intercept? What's the starting number? What's the y-intercept? What is y equal when x is 0? Or can you look on the graph? You got it in front of you too. I'm asking, where does the line cross the y-axis? Mm-hmm. You're going by ones there. Between the 3 and the 2, so yeah, I'm pretty sure it's negative 2.5. So when you put that together in an equation, what do you get? Okay. All right. Where's the what? From the slope. So Nathan noticed that this point right here is like on, where the lines cross. And then this one right here is also where the lines cross. So to get from here to here, you have to go down 2 and over 4, which is the same thing as going down 1 and over 2. Just reduced it. 2 goes into both of them. Okay. All right, let's see what Zach and Sion have to say about this. I'm afraid to see what Sion says. It was hard for me to tell where the graph crossed the y-axis. Aha! It was hard for us to tell that too. So I found 2 points that I could read easily, negative 9, 2 and negative 15, 5. And I figured out the slope was negative 1/2. Made a table. So she figured out that when the y goes down by 1, the x goes by 2. Okay? I was surprised to notice that the pattern was to start with n, add 9, multiply by the slope, and add 2. Okay, I'm going to translate that into English for you. Are you ready? All right. Here is the equation that she has come up with. What we are trying to learn here is a different form of a linear equation than our old friend y equals mx plus b. Okay? And here's how this equation that Sion has been using works. That number right there is the what? That's the slope. That's the negative 1/2. Okay? This number right here is the y coordinate of a point. And this is a little bit strange, but it's the opposite of the x coordinate. So she chose to use that point right there. So the opposite of negative 9 is plus 9, and then she went plus 2. But she also could have said negative 1/2 and then x plus 15 plus 5, and that would have been the same thing if she'd have used this point right here, the 15 and the 5. Okay? Or she could use the 11 and the 3 and go negative 1/2 times x plus 11 plus 3. Okay? So this is a new form of the linear equation that we're being introduced to a little bit. All right, Zach says, hey, I did something similar, but I used different points. And so he said, same thing, this is the slope, right? Opposite of this is negative 9, that one stays the same, negative 7. And he goes, I ended up with the equation, one of us must be wrong because yours says that you add 9 to the n and mine says that you subtract 9. How can we both be right? So for that we need to do what Luis did on the last one. And we need to distribute. So let me grab this, put it over here. Which one did you go to? Oh, nice. Okay, so if I distribute the negative 1/2, what is negative 1/2 times x? Negative 1/2 x. What is negative 1/2 times 9? negative 4.5, and then we still have the plus 2, so that works out to be negative 1/2 x. What do you get when you add these together? Negative 2.5, okay? Now let's do the same thing with Zach's. So he used different points, and he had negative 1/2 times x minus 9 minus 7. So let's go around again. What do you do? What do you get when you distribute the negative 1/2 to both of those numbers? Negative times a negative is positive. 1/2 of 9 is 4.5. And then 4.5 minus 7, negative 2.5. So it turns out those two things are the same. And if we go back to our conversation, it is the same as what we got too, okay? So those are all the same way to write the equation of line, okay? Yeah, sorry. This is your intermission music. We good? Okay. All right. I'm afraid things are about to get a little crazy and unnecessarily so, but let's see where this takes us. Zach says, my equation made me wonder if there's something special about the point 9, negative 7, since it seems to appear in my equation, x minus 9 minus 7. Huh. Yeah. Now I'm noticing something interesting. The same thing seems to happen with your equation. Okay, so they're just saying what I told you, that this number right here is the opposite of the x coordinate. This number right here is the y coordinate. This number right here, opposite of the x coordinate. This number right here is the y coordinate. Okay, so that's the pattern that Zach is noticing. The number in yes, the number in parentheses is opposite of x. Number outside parentheses, there's a pile there by my water bottle, is y. Thanks, Alexa. Okay, so that's where those numbers come from. And then the number in front we talked about before is the slope. All right? All right, so number 4 says, find another point on the line given above and write the equation that would come from Zach's pattern. So you guys have the graphs in front of you. Flip back to the graph page. Find a point on that graph that is not negative 9, 2, that is not 9, negative 7. It's got to be on the graph, though, and 0, 0 I know is not on the graph. Give me a point that's on the graph. Yep. Negative who? Negative who? Negative whoville? Negative 11, 3. Okay. McKenna, do you have a different point from that? Nathan, did you find a different point on the graph? Maria, do you have one? What's that? Finding a point on the line, yeah. What do you have, McKenna? Negative 17, 5. Okay. Talia, do you have one? Yes, Talia. Negative. Oh, but they can't both be positive 5. Oh, this one is 6. And this one is negative 15 is 5. Okay. All right, so let's use those 3 points to write the equation in this new form. Are you ready? Okay, here we go. It is y equals, what do we put down first? The slope, so negative 1/2, and then in parentheses, x and the opposite of the x-coordinate, which would be plus 11, and then the y-coordinate, which is plus 3. Okay? So in some ways that's kind of easier. You just need the slope and a point, and then you can get it into the thing. Okay? What would be the equation for this point? Awesome. Okay. Nathaniel? Grumpy. Okay, and then we'll just wrap it up with this. What would the pattern look like with the point A, B? So just any old point. If you knew that the slope was m, it would be y equals m, because that's the slope, times x. If this is positive a, we're going to go negative a plus b. Okay? So that is just a little different way to write the equation of the line, and we will work more. This seems a little easier, yeah. We'll work on that tomorrow. Yeah.